Again, who comes up with these names? I don't know. We're looking at exponential functions. I'm sorry, not exponential functions. Exponential equations. Here we go. Hardest problems we're going to do all year. JK, LOL. Chickle. Alright. That reminds me, yeah, I'm going to put this on the video. That reminds me of a story. I had a friend, and he thought that LOL means lots of love. And so he was texting these girls like he was like, yeah, so I texted this girl, and I was like, hey, let's get together, I like you. And she texted me back, LOL. He was like, I'm psyched, dude, that means lots of love. Alright. So, hey, so we're going to write this as 2 to the first power, right? What's the answer to this? What is x? X is 1. There's no trick. It's just that easy. Oh, they're backwards in your text. Sorry. So what is x? 3. It's rough. I know. Okay, ready? How about this one? I'm going to write this one as an exponent, right? And so then it must be the case that x is 4. This one's only slightly more challenging. Because I got to add 64 to both sides. So no fun. So 2 to what power is 64? Okay, let's keep going. Hang out with this one. I'll add 1 to both sides, and then I can express this as the same base, right? Which means that x is 0. Really, I just need to find the number x, right? So that my exponents are the same. So for this one, on the bottom, I'm going to write this as 2 to the 3x equals 2 to the 6, right? And then, again, with these equations, what I really care about is these two being the same. My exponents need to be the same, right? So I need to say, hey, what value of x makes this equation true? Well, 2, right? And you can see that that's true when we go back into our original equation. Okay. How about this one? So we're going to write this as 2 to the 5th, right? So again, what I really care about is just my exponents. I want to know what value of x makes my exponents the same. So that means that I can take this out and solve this equation instead, right? So x is 4. A lot of you, I'm sure, can just see that, right? You don't need to go through all of the solving. But it's worth looking at. So let's go ahead and do. It says execute, but that's not really what we're doing. I just love this problem. Okay, I think it's a great problem. It's nowhere in your book. You're gonna have to write somewhere. So the first thing I want to do is I want to write this. So I'm going to solve it 2 ways. I love the idea of taking 2 approaches to the same problem. So the first approach we're going to use is we're going to write these with the same base. And then I'm going to use properties of exponents to solve. So my properties of exponents tell me that this is actually, this whole expression over on the left is the same thing as 2 to the 2x minus x plus 5, right? I'm subtracting my exponents. Right? I'm allowed to use that property of exponents. It says that if I have a to the m over a to the n, that's equal to a to the m minus n. So I'm going to go ahead and distribute that exponent. It's 5, right? Yeah, and we can look at it, right? All we're really caring about, again, is what value of my exponent makes those things the same.
Wait, plus 5.
Nope. So x is positive. Alright, let's do it again. So let's do our second approach. We're going to go ahead and do it not using rules of exponents, but using our rules of algebra. Okay, so we're going to multiply both sides by 2 to the x plus 5. Hopefully we'll get the same answer, because the answer doesn't change, right? 1 times 2. Just multiplying both sides by that, so that I can get that out of my denominator, right? I don't want it there. I don't like it. I want it. So then what I really care about is what value of x makes my exponents the same. Oh, this should be a 2x. My bad. I accidentally didn't put the 2 there. Okay, so that means that there's a 2 there. My bad. Now we'll subtract x from both sides and get x equals 5. Fantastic. It all checks out. That's the beautiful thing. Alright, let's move right on to lesson 8. The what power function? Hey, your homework for lesson 7 is nothing.
Hey, what's going on?
Alright. Hey, this is real. Logarithmic? So we're going to talk about logarithms. I can't make a beat, but I got math logarithms. Ooh. What? Ooh. I don't know what you just said, but that's not hard. I don't need a beat. You gotta think about that for a while. Go back and watch the video. What video? I'm recording right now. I record a video every time during this class, so I love you guys so much. Alright guys, so this is how we're going to say this, okay? We're going to say b to what power is a, okay? When we want to take a logarithm and we want to write it as an exponential equation, that's how we're going to do it. We're going to say b to what power is A, right? This is pretty much a very important thing. It's not pretty much, it's really important. You really need to know this. This property is written in the rectangle at the end of the lesson. But this is a nice way to write it. I like this representation of it a lot. Alright, so let's use this what power function. What power? So what am I saying? I'm saying, hey, 4, so what power is 64? Look at that. So we're saying 4 to the third is 64. So we're going to rewrite these ones in logarithmic form. So we're going to say log base 5 of 25 equals 2. That's how we're going to rewrite it, okay? Log base, and it's cool because what is the base of my exponent? It's 2, right? So the base of my log is 2. Of 1/8 is -3. So we're saying 2 to the -3 power is 1/8. All right, and lastly, log base 1/16 of 1/4 is equal to 1. Did we show mercy to still down? Show no mercy. Beat dead horses. All right. Okay. So now we're going to rewrite the logarithms in exponential form. So we're going to say, hey, 4 to the 4th power is equal to 256. You see how it's just a different way of writing an exponential equation. So this one is 6 to the -2 power. 6 to the -2 is equal to 136. That's true, right? So our base is 1/2, so we could say 1/2 to the -3 power is equal to 8. That's another way of writing it. I knew it. All right, here we go. So we are now going to evaluate logarithms, okay? So 2 to the 8th power is 3. Why? Because 2 to the 3rd power is 8. Hey, log base 3 of 9 is 2. Why? Because 3 to the 2nd power is 9. Okay. So then let's do number 3. So 6 to what power is 36? 2. That's how we do these, okay? Hey, 2 to what power is 32? 5. So then log base 2 of 32 is 5. 10 to what power is 1,000? 3. 42 to what power is 1? Ooh. Here you go. We'll step it up a little bit. 100 to what power is 0.01? Okay, so what is 0.01? Isn't that the same thing as 100? How would we express that as an exponent? Yeah, that's the same thing as 100 to the negative 1 power, right? So, boom. All right, 2 to what power is 1/4?
1/2. -2.
Negative 2. 1/2 will give me a radical, right? Yeah. All right. Moving right along. How about these? 2 to what power is 32? 5. So we could rewrite that saying that 2 to the 5th power is 32, right? 2 to the 5th power is 32. Over here, 3 to what power is 81? 4. So we could write that as 3 to the 4th power equals 81. How about this one? 9 to what power is 81? 2. Okay. Hey, 5 to what power is 625?
4.
4. So that would be that 5 to the 4th is equal to 625. We're going to write that as an exponential function. Exponential equation. Hey, 10 to what power is 1 billion? 8. And I don't want to write all those zeros, so. How about 1,000? 1,000 to what power is 1 billion? Huh? You know you won. Hey, 13 to what power is 13? 1. So we could write that as 13 to the 1st power equals 13. Alright. Alright, how about 13 to what power is 1? 0. So we could say that 13 to the 0th power equals 1. It looks like we kind of have a rule there, right? That doesn't matter what our base is of our log. If we have a 1 in there, the answer is always 0, right? Write this one on the side. This one's not in your book, but it is. Where is it?
Yeah, it's below it.
Oh,
Yeah, it's right below it.
it's J. Okay, 9
Yep,
to what power is 27.
So you can get some, bro.
And don't forget, you can have fraction exponents, right?
1 over 3.
Let's see. 1 over 3. So you're saying that 9, the cube root of 9 is 27. What about the square root of 9 cubed? I know, that's crazy, right? The square root of 9 cubed. That works, right? How would we write that? Right? That's how we would raise something to the 3/2 power if we wanted to take the square root and then cube it, right? Let's write that down real quick, okay? Check it out. 9 to the 3/2 power is equal to 27. Why? Because I can write this as the square root of 9 . That's the weirdest one of them all, in my opinion. It's quite strange. Let's move on to the others. Good? Hey! 7 to what power is the square root of 7?
1/2.
1/2, right? Okay. Hey, the square root of 7 to what power is 7? Yes. Right? Why? Because let's write that. Square root of 7 squared is equal to 7 to the 1/2. Right? Okay, so now the square root of 7 to what power is 1 over 49? That's crazy. Let's look at it. Okay. Let's write the square root of 7 is the same thing as 7 to the 1/2, right? What would I need to put here? It's not a 0, okay? It's like I should put a box instead. Because boxes don't look like 0. What needs to go in here to make this 1 over 49? Let's actually write this a different way. Let's call it 1 over 7 squared, right? How did we get that? In other words, how about this? 7 to the, it's the same thing, 7 to the negative 2 power, right? So 1/2 times x equals negative 2. That's another way to look at it, right? I'm thinking the answer to that is negative 4. All right. Just giving you a bunch of different approaches to these, okay? You can always bust out your algebra, make a linear equation for it, okay? This one is the hardest one of them all. Right? It's T! Thanks for watching the video! You're all very special! And I mean that in a nice way. So, your homework is 4, 5, and 9.